Good afternoon, students. So we'll quickly begin with our lecture. We're going to continue with circles chapter, as I had said the last time. So we had already started the circles chapter the last time. We're revising the circles chapter. In our chapter, we have only two theorems which we have already studied about. What were the two theorems, people? The first theorem we had was radius is perpendicular to the tangent. Yes, radius is always perpendicular to the tangent. So this was the first theorem. The second theorem we had studied was tangent segments from an external point to a circle are equal. Yes, tangent segments from an external point to a circle are equal. Let's quickly see what that means before we move ahead. So we're quickly gonna try and see what that actually means. All right, so from an external point P, let me have two tangent segments to this circle. Say we have PA and we have another tangent segment, say PB. Okay, just consider them to be tangent segments for now. All right, so we have seen from an external point to a circle, two tangent segments. Let's quickly revise what tangent segments are. Okay, Rahul. All right, that's great. You can hear me. All right. Tangent segments are, it's a segment with one endpoint as a point on the tangent line. The other endpoint is always the point of contact. The other endpoint is always the point of contact. So such segments are known as tangent segments. From one external point, you can have only two tangent segments and they are equal. So keeping these two theorems in mind, we're going to solve the rest of the sums. In today's lecture, we're going to solve all the slightly trickier sums in our circles chapter. Yes, we've already studied the basics, we've studied the concepts. Now it's time to apply those concepts. So let's quickly move. Okay, so the first sum, like I had promised, we'll be studying how to attack a problem. More than focusing on what steps we need to write, you'll already know what steps are to be followed. We'll brush through the steps, but how do you start looking at a problem is what we need to see. Okay, so let's begin with the first sum for the lecture today. If tangents PA and PB, students observe, P is an external point. We have two tangents PA and PB, where A and B are the points of contact. Okay, so there are two tangents to a circle with center O, inclined to each other at an angle of 80 degrees. So what do we see? Angle P is given to be 80 degrees. What we need to find is angle POA, the angle which has been marked for you. We need to find that angle. Now students, pay attention. Everything that's given to us, let's analyze it one at a time. First thing, from an external point, two tangent segments at the point of contact A and B. So what can I say about PA and PB, students? Yes, come on, let's make it interactive. PA and PB. What can I talk about PA and PB? Yes, students, what do we know about segments PA and segment PB? Yes, come on, quickly type in the chat box. Come on, yes, Rehan says they're equal. Okay, Rehan, thank you. Ajay says they're equal. Yes, students, they are definitely equal. Just now we had studied tangents from an external point. Yes, thank you so much, Rahul. Tangents from an external point to a circle are equal. So PA equal to PB. That's the first theorem we have applied. Now let's see if we can apply the other theorems. What did the other theorem say? Radius is always perpendicular to the tangent at the point of contact. So we have two points of contact, A and B. We have radius OA perpendicular to tangent AP, radius OB perpendicular to tangent PB. Yes, students, so can I say angle A and angle B each are 90? Can anyone tell me what is the measure of angle what is the measure of angle BOA? Measure of angle BOA. Come on, quickly tell me. Measure of angle BOA. I'm talking about this entire angle BOA. Yes. Can anyone tell me what is the measure of angle BOA? Yes, students, quick. I'm waiting for you all. 100. Ajay says 120. Ajay, can you tell me why 120? Yes, 120. How do you get this number? 120. Rahul, okay. All right, students, pay attention. APBO. APBO. What is it? It's a quadrilateral, right? What are sum of angles of a quadrilateral? Sum of angles of a quadrilateral is? It's 360. Yes, that's correct. 360. So 80 plus 90 plus 90 plus O is 360. Remaining angle O is definitely going to be 100. Angle O is 100 degrees. Yes, everyone. Yes, Rehan, that's correct. Okay. So angle O is 100 degrees. Yeah. Okay. Now, students, pay attention. But do we need angle O? No. What we need is angle POA, which is a part of angle O. Yes. So let's quickly see how do you get POA from O. Now, students, pay attention. Since we know that the entire angle is 100 degrees, what we can do is we just need one part of this entire triangle. Yes? Yes, Rahul, okay, I see 50. All right, students, now pay attention. What do we see about triangle POA and POB? They are two triangles. Yes? Can I prove those two triangles congruent? Come on, students. I'm talking about triangle POA and triangle POB. Can the two triangles be congruent? Yes, yes, they can be congruent. By which test can I get them congruent? Come on. Okay, Ajay says SAS. All right, let's see what is SAS. This side congruent to this side. The right angle congruent to the right angle. Radius congruent to radius. Yes, SAS is correct. Rahul says RHS. And you know what, student? RHS is also correct. Let's see why. We have the right angle. We have hypotenuse OP, which is the common side. And again, you can either take AP and PB as the corresponding side or OA and OB. So RHS is also correct. Yes, and look at the beauty, students. Prathamesh says SSS, and that is also correct. OP is the common side. AP and PB are tangents from an external point to a circle. They are equal. OA and OB are the radii. So take whatever test you want, but by either SSS or SAS or RHS test, the two triangles are congruent. You can use any of the three ways, prove the triangles congruent, and we know once the triangles are congruent, students, what we can say is angle POA. Students, pay attention. Once the triangles are congruent, they have used SSS, but you can also use RHS and SAS. Once the triangles are congruent, let's look at the two angles that we need, POA and POB. They are congruent by CPCT. You can also write CACT for corresponding angles of congruent triangles. Yes, so once the angles are congruent to each other, together it's 100. So POA is half of 100, which is going to be 50 degrees. Definitely POA has to be 50 degrees. Yes, students, any doubts with this? Have you all understood this? So I believe this is an extremely easy sum, nothing to worry about. So let's move to the next sum. All right, Ajay, okay, thank you so much. Let's quickly move to the next sum now. All right. Now, students, I would request all of y'all to pay attention to the sum. It's not at all difficult, but try to understand how we are going to approach towards the sum. We have two tangents TP and TQ. It's also marked from an external point. Two tangents, they are equal. We already know that. Next, they're drawn to a circle with center O. Okay, we see that from an external point T. All right, this is all the information we have. Let's look at what you need to prove. We need angle PTQ. Okay, so angle PTQ is this angle, should be equal to 2 times angle OPQ. OPQ is this angle. So students, pay attention. I've marked these angles for you so that we can see that we need some relation between these two angles. Okay, now I'm going to change my color so that we can start proving this. Students, steps I'm not worried about. Let's quickly look at how we look at this sum. Now, TP and TQ are congruent to each other. Yes, are TP and TQ also two sides of a triangle? Yes, they are two sides of triangle TPQ, right? So that means TPQ triangle is what kind of a triangle, students? It's an isosceles triangle. Yes, triangle TPQ is an isosceles triangle. Now quickly tell me, in an isosceles triangle, if two sides are equal, there are two angles which should be equal, right? Two angles which are equal. Come on, quickly type the pair of angles which are congruent in triangle TPQ. Angles which are congruent in triangle TPQ. Come on, quickly. I'm expecting that answer from y'all. Yes, so it's TPQ and TQP. Yes, so Ajay says TPQ. All right, Ajay says angle TPQ and angle TQP. Okay, so does Yash. Okay, yes, Rahul. All right, very good, students. That's absolutely correct. Angle TPQ and angle TQP are congruent to each other. Now, quickly, students, I would always suggest whenever you find two angles congruent, Just take those two angles and give them a common letter. Yes, it's so easy to give them a common letter. Next time we can refer to these angles as x. So students, whenever you name two angles with some letter, please do not forget to mention that in your steps. Okay, so we'll just say let tpq equal to tqp equal to x. Yes, and we can either say angles opposite to equal sides or just isosceles triangle theorem. Either which ways, these are x and x. Now students, pay attention. We are only concerned about which angle? Yes, students, we are concerned about angle PTQ. Now, PTQ is this angle. So can I get the value of PTQ with respect to this? Yes, students, we already know that PTQ plus x is equal to 180 degrees. Yes, just normal angle sum property. So can I say PTQ is 180 minus 2x? Yes, students, I would like anyone who has not understood this step, I would like you all to comment in the chat box. Anyone who has not understood, please, I would request only those people to comment right now. Anyone who doesn't understand why PTQ is 180 minus 2x. Okay, so since I see no answer, I believe everyone has understood how PTQ is 180 minus 2x. Students, just a simple angle sum property. Now pay attention. We need PTQ equal to 2 times OPQ. Yes, we need PTQ equal to 2 times OPQ. Okay, Rahul, okay, you have not understood. All right, Rahul, no problem. Let me elaborate for you then. So what do we have? In triangle TPQ, angle PTQ plus TPQ. So angle PTQ is this, TPQ is this, and TQP is equal to 180. Yes, we definitely know. Just simple angle sum property of a triangle. Now let's substitute. PTQ, we can do nothing about it because we have to find it. But TPQ and TQP. Pay attention, students. TPQ and TQP are x and x. Yes. So what do we get? What we get is, students, pay attention. I am solving from this step. Okay. So PTQ plus TPQ plus TQP is 180. But PTQ, we leave it as it is. TPQ is x, TQP is x. So now I'm going to write PTQ plus x is equal to 180 degrees. Yes. Now what does that mean? PTQ plus 2x is equal to 180 degrees. Yes, definitely PTQ plus 2x is 180. Since I want only the value of PTQ, I will shift 2x on the other side. Plus 2x becomes minus 2x. So I have shifted 2x on the other side, and that's how we get this equation. PTQ is equal to 180 minus 2x. Rahul, I hope I have solved your doubt. Yes, you can just quickly confirm that now you have no doubts. Okay. Meanwhile, we have understood PTQ is 180 minus 2x. Okay, thank you so much, Rahul. Now pay attention. Look at what is in the sum. Always keep looking at what you need to prove. We need PTQ to be 2 times OPQ. PTQ should be 2 times OPQ. That means, is it wrong to say that value of OPQ should be half of PTQ? Yes, if you shift 2 on the other side, what do we get? OPQ is half of TPQ. Yes, Yash, all right, you're welcome. Yes, so OPQ is half of PTQ. Now, what is half of 180 minus 2x? Is it 90 minus x? Half of PTQ is 90 minus x. Is that correct? Yes, students, anyone who has not understood this, this needs to be proved. We need to prove that OPQ is 90 minus x because OPQ is half of PTQ. ये हमें prove करना है. Anyone who did not understand this step? Okay, all right. So let's quickly move ahead and let's try to prove OPQ as 90 minus x. Why? This we will prove because we already know that PTQ is equal to 180 minus 2x. Now students, pay attention. अगर ये prove करना है, let's look at OPQ for that. Now, time for the next theorem in our circles chapter. What is the measure of angle OPT? Quickly, students, I want you all to type in the chat box. What is the measure of angle OPT? 90. Rehan says 90. Okay, that's all right. Rehan says 90. Anyone else? What do you think? Is it 90 or what is it? Or cannot say? Yes, 90. Rahul says 90. Yash, okay, all right. Very good, students. Yes, definitely OPT is 90 degrees, right? Because radius OP is perpendicular to tangent TP at the point of contact P. Now students, pay attention. Angle OPT is 90 degrees, and it is also equal to angle OPQ plus angle TPQ. Yes, can I say angle OPT? Angle OPT is measure of angle OPQ plus TPQ, obviously. Now, OPT we know is 90 degrees. OPQ we need to find. And what is TPQ? We had just taken it as X, right? TPQ and TQP were X and X. So can I say TPQ is X? And what do we get the value of OPQ? Just shift X on the other side and you will get the value of OPQ as 90 minus X. Yes, students, value of OPQ is now going to be 90 minus X. And we can clearly see if OPQ is 90 minus X, 2 times OPQ is going to be 2 into 90 minus X, which is 180 minus 2X, which is 180 minus 2X, the value of angle PTQ. Yes, students, have you all understood how to target this sum? What steps you need to follow? Yes, anyone who has any doubts with this sum, this is a really good sum. So anyone, if you all have any doubts with any step, please either raise your hand, you have an option to raise your hand, or you can also post your query in the chat box. And if you have understood, I would just request you all to say yes, you all have understood, or just a yes. Come on students, quickly before we move to the next sum, I need to know if there are any doubts with this one. Okay, all right, thanks Rahul. Okay, yes, Yash. All right, that's perfect. Okay. All right, so I believe no doubts, right? So we move ahead. Students, let's move to the next sum. All right, so we move to the next sum now. Okay, now these are extremely easy sums, students. The last time we had left at a place where if a quadrilateral circumscribes a circle, then every vertex of the quadrilateral become external points for the circle, and we have some pairs of congruent tangent segments. Yes, the same thing happens out here, right? We have a quadrilateral ABCD circumscribing a circle. Yes, and what are the points of contact? P, Q, R, and S. So now, can I quickly say that A is the exterior point to the circle? So what can I conclude about AP and AS? AP and AS. Yes, students, what do I know about AP and AS? These two segments. Come on, what do I know about them? AP and AS. Yes, I'm waiting. Come on, students. Okay. All right, come on, quick. Those who are busy daydreaming, come on, I'd like you all to participate. Pay attention. A is an external point. AP and AS are two tangent segments from an external points. Yes, they are tangent segments, and yes, we have a beautiful theorem around it. Tangent segments from an external point to a circle are equal. So can I say AP equal to AS? Yes, very good. Similarly, PB and BQ. PB and BQ are also equal to each other. So PB equal to BQ. Yes, that's correct. Now look at RC and CQ. Students, RC is going to be equal to CQ. That's correct. So RC equal to CQ. And the last one, DR equal to DS. I'm just going to mark them congruent. DR equal to DS. Now, students, if you paid attention to how I have written the segments, I've put them down very smartly. Why smartly? Pay attention. I could also write BQ here and PB here, right? But I chose to write PB here and BQ here. Why? Pay attention. So this is equation 1, 2, 3, and 4. Students, now pay attention to why I have written it this way. We need AB plus CD, right? Now AB is AP plus PB. So I've written AP and PB next to each other. CD is RD plus CR. So I've written RC and DR. Yes, RC and DR also next to each other. Yes, which is why I have exactly chosen these segments and written them one below each other. Now, extremely easy, right? We just need to add 1, 2, 3, 4. So students, pay attention. Now what we have done is we have added those same 1, 2, 3, and 4. Just add the left hand sides, add the right hand sides. So it's very easy, right? We were very smart to write them together. AP plus PB is equal to AB. CR plus RD is equal to CD. We have already got the left hand side. Now let's look on the right hand side. What do we have? AS, BQ, CQ, DS. AS is here, BQ is here, nothing in common. But what about AS and DS? Yes, AS and DS form the single segment which is AD. And so now we obviously have no choice but to group BQ and CQ. And BQ and CQ form the next segment which is BC. And there we go. We have got what we wanted, right? We have hence proved this part. We had to prove this part and it's hence proved. Yes, students, any doubts with the sum? This is an extremely easy sum. So I hope you all have no doubts with such sums. We'll quickly move ahead to the next one. Okay. Now, again, an extremely easy sum. People, whenever I talk about certain rules or something that has to be there, you should make a note of that. For example, now I'm going to talk about a third rule. In figure xy and x dash y dash, they are two parallel tangents. So xy and x dash y dash are two parallel tangents. Just remember them. I'm just going to mark the parallel sign. Okay, and we'll see when to use that. Next, what do we have? So parallel tangents to a circle with center O, all right. Another tangent AB. We have another tangent AB with point of contact C. Yes, we can see that. It intersects XY in A, X dash Y dash in B. All right, this is all the information we have describing this figure that we have. All right. We need to prove that angle AOB is a right angle. Prove angle AOB to be 90 degrees. Now students, before we move to anything, this is an important thumb rule. Whenever you have the center given and the points of contact, students, remember, center of the circle and point of contact between the tangent and the circle, you need to always join them. Yes, always join the radius between the center and the point of contact. Now, O is the center, P is the point of contact, it's joined, no problem there. O is the center, Q is the point of contact, again we have joined it, but O is the center and C is the point of contact. We have not joined this segment, so let us join that. Before we do anything, we will join that. Now students, pay attention. We need to get angle AOB, and now angle AOB is divided into two parts, AOC and BOC. Now quickly start paying attention. Let us look at triangle POA. Students, triangle POA and triangle AOC. Triangle POA is this triangle, AOC is this triangle. Can you try to get these two triangles congruent? Yes, students, our triangles POA, this triangle, and AOC, which is this triangle, can you prove them congruent? Come on, try to prove these two triangles congruent. Yes, come on, I would like you all to tell me by which test. Okay, Rahul says RHS. All right, any other test which applies? Yes, students, RHS. Okay, Yash also use the RHS test. Yes, Rahul. Rahul uses the SSS test. And any other test. Just a while back we had seen. Whenever we have such a scenario, there are three tests by which the triangles are congruent. Which is the third one? Third way. Yes, Rahul, very good. SAS test as well. Yes, students, we have already seen this, so I will not be talking on that again. Quickly observe RHS test. We have two right angles. Radius is perpendicular to the tangent. Same here. What do we have? Radius perpendicular to the tangent. Yes, radius is perpendicular to the tangent. We have a common side. Also, what do we have? A is the exterior point and AP and AC are two tangent segments, so they are also congruent. OP and OC are the radii, they are also congruent. Use any permutation combination and you will get the two triangles congruent by either SSS test, SAS test, or RHS test. Yes, by any test you can get them congruent. What we are interested in is, students, pay attention, once the two triangles are congruent, can I say that angle POA is congruent to angle AOC by CPCT or CACT? Yes, what have I said? Once the two triangles are congruent, POA congruent to AOC by CPCT. So can I mark them as X and X? Yes, definitely. So I can say these two angles are congruent, let them be X. Now students, we have a very beautiful concept in geometry. If you need to prove two other triangles congruent the same way. If you need to repeat the same steps for some other figure, you can directly say similarly. This is the magic word, say similarly. We can get COB congruent to QOB. COB congruent to QOB, and let's name them as Y. Students, in geometry, whenever you have congruent angles, always give them a common letter. Two angles congruent, let's give them a letter X. Other two angles congruent, let's give them a letter Y. That makes our life very easy. Now look at X, X, Y, Y. X, X, Y, Y. They are angles on a straight line PQ. Yes, so can I say X plus Y is equal to 180 degrees? Yes, students, I can always say X plus Y is 180 degrees. Now, that gives me 2x plus 2y is equal to 180 degrees. Now we have almost reached our destination. We take 2 common. What remains in the bracket is x from here and y from here equal to 180. So students, what do we get? X plus y is 180 upon 2, which is 90. Yes, that's correct, Rahul. X plus y is 90. Let's look at x plus y. Are we interested in x plus y? No, we're interested in AOB, right? So let's see. Let's look at AOB. AOB. Isn't AOB AOC plus COB? Yes, AOC is x, COB is y. So can I write x plus y as AOC plus COB, which is x plus y, which is equal to 90? Yes, students, we have written it as COA plus COB equal to x plus y equal to 90. Yes, students, have you all understood this sum? Yes, and hence proved AOB is equal to 90 degrees. So this is how you go about a particular sum. All right, now we move ahead. We already know every step in geometry needs to be on paper. Anything that is not given to you, anything that you analyze, please do not do it in your mind. Everything, please write it down on the paper and keep giving reasons everywhere. Always give reference numbers to statements so that they can be used later on to give them as reasons. All right, okay. So I believe no one has any doubts. We can move to the next sum. Students, at any point of time, if you have any problem, you can always raise your hand and type in your question or your doubt, or else in the chat box as well. Okay, before we proceed, I'd like y'all to tell me if any one of y'all are from City International Aund or Wanavdi. If not, you can also type in your branch name. If you're associated with Mahesh Tutorials, please type in your branch name. All right, I'll leave you all to do that. Meanwhile, I'll go ahead. Okay. Another beautiful sum. PA and PB are tangents from an external point P to a circle. Students, pay attention. PA and PB tangents from one external point to a circle. So quickly, students, first thing what we understand is PA equal to PB. Yes, students, now this is nothing new for us. P is an external point. PA and PB are two tangents from that external point. So PA equal to PB. Okay, this is all that we know, right, from the given information. Let's look at the diagram. Do we have any more external points, any more congruent tangent segments? Yes, come on, students. I'd like you all to reply in the chat box. Any more external points to the circle? Yes, we know from an external point there are two congruent tangent segments. So any more external points? Okay, Rahul says L and N. Okay, let's look at L and let's look at N. Yes, L and N are definitely external points to the circle. External points are just points outside the circle. Okay, now from L we also have two tangent segments which are equal. Let's quickly write about them. Can I say AL is equal to LM? Yes, obviously AL and LM are two tangent segments. Also, MN is equal to BN. Yes, Prathamesh, very good. That's correct. LM and LA are equal. Yes, that's our second statement. This is our first statement. And from N, which is an external point, we have NB and NM equal. So we have NB and NM equal. Let's mark that as a third segment. Now, everything that is given or that has to be analyzed, we have written. Now let's move to what we need. We need PL plus LM equal to PN plus MN. Okay, we have PL plus LM equal to PN plus NM. All right, students. Now we already know that PL is a part of PA. right? PL is a part of PA. So let's quickly do one thing. Let's write PA and PB again and let's try to solve from them. So we know PA equal to PB. Now PA is divided into two parts. PA is divided into PL plus AL. Yes, that's correct. Let's forget what they want. Let's start with what we have. Since they want PL and PL is a part of PA, we're going to talk about PA and PB for now. So PA is PL plus AL. What about PB? PB is also divided into two parts. They are PN plus NB. Now that we have got one equation, let's call it number 4. Let's look at what we have and what they want. They want PL on LHS, we have it, so we will not touch PL. They want LM and we have AL. Students, can I do something to replace AL with LM? Let's see, let's look at 2. Yes, AL is equal to LM, right? So instead of AL, can I directly write, instead of AL from 2, I can write, sorry, that's a plus, I can write LM. Yes, instead of AL, I can write LM. Now on the other side, they want PN, we have PN. No touching it, we will keep it just that way. Now, instead of NB, they want MN. Look at the equation where we are talking about NB and NM. They're equal, right? So that's it, just replace it. What are you all waiting for? Yeah, so instead of NB, I'm just gonna write NM. What we have got, doesn't it look like what we had to prove? So that's it, hence proved. We have got what we wanted, hence proved. Yes, students, any problem? Yes, from 2, 3 and also 4, right? From 4, 2 and 3, we have got what we wanted. So the reason will be from 2, 3 and 4. Yes, Rahul, it's going to be 2, 3 and also with the help of 4 because we have substituted in 4 as well. Yes, so from 2, 3 and 4, we have got what we wanted. Yes, that's how we write that. Okay, now let's move to the next sum, students. This sum is just very similar to the previous sum. Now, why do I say that? You will understand. Let's quickly read the sum. What do we have? A circle touching side BC. Okay, so a circle touching side BC of a triangle ABC. Now, where is it touching this triangle? At point P. Okay, and AC produced at Q. So what do we have? AC. Okay, pay attention. AB and AC are produced at Q and R. So we have extended AB to a point Q. Q is the next point of contact. We have extended AC to a point R. R is also a point of contact. Now, students, again, if you observe, how many exterior points do you see? How many do you see? And please name them in the chat box. Okay, Rahul says 3. All right. Can you all name those points? How many? 1, 2, 3, whatever. Okay, A, B, C. Yes, Ajay. Thank you so much. Yes, Rahul. Yes, Yash. There are 3 points. Definitely, right? A, B, and C, all 3 are exterior points to the circle. Now let's quickly write the tangent segments coming from each of these exterior points. Always start from what you know, and then we will move towards what we need. So definitely from A, what do we have? AQ and AR. Always remember, external point to a point of contact. Do not stop till you find a point of contact. Yes, don't be in a hurry to just write something. So A to Q makes one segment and AR. Same external point, so AQ equal to AR. Similarly now, BP, P is the third external point, equal to BQ. So BP equal to BQ, and same way CP equal to CR. So we have CP equal to CR. This is what we analyze or what is given from the diagram. Now let's quickly move to what we need to prove. We need to prove that AQ is equal to half perimeter of triangle ABC. Students, perimeter of triangle ABC. Now look at AQ. AQ is one side. Yes, AQ is this one side. We need AQ equal to half perimeter of ABC. Now what is perimeter of triangle ABC? What is perimeter in general? We all know perimeter of anything is just sum of the sides of that polygon. If a triangle, then it's sum of 3 sides of a triangle. So perimeter is nothing but, so I'm going to write P of ABC is nothing but AB plus BC plus AC. Yes, that is what perimeter is, and we need half of this. So basically we need half of the perimeter. Now let's quickly look at what we have and what we have to start with. So I already showed you all perimeter is AB plus BC plus AC. Now let's quickly look at what we can do with this. AB, side AB, we can keep it as it is, but look at BC. Isn't BC divided into two parts? Yes, BC is BP plus PC. So I'm going to break BC and write BP plus PC. AC again is the third side of the triangle. We'll leave it as it is. Now again, students, let's try to group from the information that we have. AB, do we have anything about AB in these three equations? No. So leave AB as it is. But what about BP? BP is equal to something, right? Yes, BP is equal to BQ. So instead of BP, now I'm going to write BQ. CP is also equal to something, and that is CR. So instead of CP, we will write CR. Yes, there's no point of writing this information if you're not going to use it. So you have to definitely use the given information. Always remember, whenever you're stuck at any point in a sum, revisit the question or the diagram and try to see if there's any given part which has not been used. All right. So yes, these are two things which we have analyzed. We have substituted CP with CR. AC, again, we have no equation related to AC, so we keep it as it is. Now, students, let me group AB and BQ. AB and BQ. Yes, what is AB plus BQ, students? Isn't it AQ? Definitely it's AQ. Look at CR and AC. We are going to group CR and AC. CR and AC form AR. Okay, so what we have understood is perimeter of triangle ABC is AQ plus AR. But what do I want? I want AQ to be half perimeter of ABC. That means perimeter of ABC should be 2 times AQ. 2 times AQ. We have 1 AQ, 1 AR. Time to go to the first equation. AQ is equal to AR. So just replace AR with AQ. So perimeter of ABC is AQ plus AQ. It is twice AQ. Shift 2 on the other side. Multiplication becomes division. AQ is half perimeter of ABC. Yes, students, any doubts with this sum? Anything that you have not understood in this sum? If any doubts, please type. Okay, no problem. I don't see any problem out there. Okay, so then I think we can happily move to the next sum. All right, let's move to the next sum. Okay, now parallelogram circumscribing a circle is a rhombus. What do we need to prove? That there is a parallelogram ABCD and we need to show that ABCD is a rhombus. Now students, for this, first thing you need to know properties of a parallelogram and properties of a rhombus. We know that a parallelogram is a quadrilateral in which opposite sides are parallel and opposite sides are equal. Yes, we already know opposite sides are equal. All sides are equal and parallel. Rahul, what is that about? A parallelogram? Dear, only opposite sides are equal and parallel. You can't say all sides are equal and parallel. Yes, it's not possible for AD and CD to be parallel to each other. Yes, so only opposite sides. That means CD parallel to AB. This is about a parallelogram and CD is equal to AB. I've written it together, parallel and equal. Similarly, AD is parallel to BC and AD is also equal to BC. All right, this is what we know about a parallelogram. But what do we need in a rhombus? In a rhombus, students, in a rhombus, we need all sides equal. Yes, for a rhombus, the basic definition of a rhombus says that all sides equal. That means AB equal to BC equal to CD equal to AD. That means, students, do you really think we need to prove all these sides equal? That means I have to, in my sum, I need to show AB equal to BC equal to CD equal to AD. Should it be that lengthy? Do you really think it should be that lengthy? No, we don't have to show all sides equal, students. It is sufficient to show AB equal to BC. Now, why do I say that? AB and BC are a pair of adjacent sides. Yes, AB and BC are a pair of adjacent sides. Okay, people, I need you all to stop fighting over the chat box. Okay, so AB and BC are just adjacent sides and we will only prove these two sides equal. Why? Because we know AB is already equal to CD. BC is already equal to AD. So if AB is equal to BC, BC will also be equal to CD. AB will also be equal to AD. Yes, because they are equal to each other. They are opposite sides of a parallelogram. So all we are going to prove is one pair of adjacent sides to be equal. Yes, that is all we need. If a quadrilateral is a parallelogram, to prove that it is a rhombus, we just need one pair of adjacent sides to be congruent. Okay. So now I have concluded that I am going to prove AB and BC congruent. Okay, that is my hint. AB and BC, I will prove them to be congruent. Now let's look at the steps to do that. Okay, now pay attention. Again, quadrilateral circumscribing a circle. Yes, quadrilateral circumscribing a circle. All vertices of the quadrilateral are external points for the circle, and from every external point we have two tangent segments, right? Let's quickly note them. AR equal to RB. Sorry, AR equal to AS. Yes, from A, look at the external point and move till the point of contact. Move till the point of contact. So AR equal to AS. Now, what do we have from B? BR equal to BQ. So we have marked that BR equal to BQ. Similarly, CP equal to CQ, DP equal to DS. CP equal to CQ, DP equal to DS. Now, students, again we have acted very smart. We need AB equal to BS. So what we have done, we have kept all the parts of AB on one side, all the parts of BC, which is BQ and QC, on the other side. Yes, so automatically the remaining will come on left hand side and right hand side. Now, why have we done that? Because we need AB on the left hand side, BC on the right hand side. Now, students, again, very easy. Let's add 1, 2, 3, 4. Before doing anything, let's add 1, 2, 3, 4. So AR plus BR plus CP plus PD, left hand side add on the left hand side, right hand side, we together add it on the right hand side. Now again, let's group it. AR and BR. AR and BR form AB. CP and PD form CD. On this side, we have grouped AS and DS. So we have grouped AS and DS, which forms AD. AS plus DS is AD and BQ plus QC is BC. Now students, pay attention. What do we need? Let's look at what do we need. Let's quickly look at our hint. We need AB equal to BC, right? We only need AB and BC, but look at this. These are extra alien items which we don't want, but we cannot just remove them. So what are we going to do? Pay attention now. Students, we already know that AB and CD are opposite sides of a parallelogram, so they are equal. Yes, we already know opposite sides of a parallelogram are equal. So AB is equal to CD. Instead of CD, I can write AB then. Yes, look at AD and BC as well. AD and BC, again, remaining opposite sides of a parallelogram. AD is equal to BC. So instead of AD, can I write BC? I am only substituting what I don't want. I want AB, I want BC. So if CD is equal to AB, I've written CD as AB. AD is equal to BC. So we have written this as BC. Now what is the equation? 2AB plus 2BC, right? Sorry, we have 2AB equal to 2BC. So what do we have? 2AB equal to 2BC. Just cancel those 2's. And what do we have? AB equal to BC. Yes, a pair of adjacent sides in a parallelogram are equal, and if a pair of adjacent sides are equal, a parallelogram automatically becomes a rhombus. Yes, students, is that understood? And pay attention, a circle, if it has any parallelogram around it, it has to be a rhombus because all sides have to be equal. Circle is symmetric, so the figure also should be symmetric. I hope you understand that. Yes, so we have hence proved this sum. If any doubts, people, you can always raise hands or ask. Yes, okay. All right. Okay, no doubts. Okay. Similarly, students, if it is said the same thing, like this sum, we can have a similar sum. This sum says parallelogram circumscribing a circle should be a rhombus. Similar sum you can have rectangle circumscribing a circle is a square. This is a variation to the same sum. You can take this down and you can try to prove this. Rectangle circumscribing a circle is a square. Try to solve this sum and you will get the same result that a rectangle around a circle will always be a square. Why? Again, circle is symmetric, so a rectangle should actually be a square. Yes? Okay. All right, so we move ahead. I leave you there. You can go ahead and solve this at home if you want to. We move ahead. Now let's move to a slightly different pattern of sums. A circle is inscribed in a triangle ABC. Students, again pay attention. Circle inside a polygon. Yes, circle inside a polygon is any figure having more than two sides. So three or more sides. A triangle is a polygon, a quadrilateral is a polygon. Any figure having more than two sides is a polygon. So again, circle inside a triangle, vertices of a triangle become external points to the circle, and again we can have tangent segments which are equal. But this time let's see what do we need to do with them. Now they have said triangle has sides 8 centimeter, 12 centimeter and 10 centimeter. You can take any side as any value since they have not specified. Yes, you can take AB as 8, BC as 10, AC as 12. No problem. There's no problem with that. Okay. Now, pay attention to what they want. They want us to find AD, which is this tangent segment AD. Next, they want us to find BE, which is another tangent segment from external point B. And the third tangent segment CF from external point C. Okay, since we have to find tangent segments, first thing we have to write the property that we know about tangent segments. Let's quickly do that. So what have we done? We have used the tangent segment property, AD equal to AF, BD equal to BE and CF equal to C. Now students, because we have to find those tangent segments, as soon as you write that the tangent segments are equal, let's give them particular names. So I have named AD and AF as X, BD and BE as Y, CF and CE as Z. Because we have to find them, we are going to name them this time. Now students, if you have to find X, Y, Z, what do we have? Three unknowns, right? AD, we have to find AD. AD means we have to find X. BE, BE, we have named it as Y. That means we have to find Y. And CF is Z. So basically, we have to find all X, Y, and Z. Yes? Now, in algebra, you have always studied if you have three unknown quantities. To solve three unknown quantities, students, I've always mentioned how many equations do you need to solve three unknown variables? How many equations? 1, 2, 3, infinite. What do you think? How many equations do I need to solve X, Y, and Z? Okay, I see 3. Prathamesh says 3. Rahul says 3. Okay, can I not do it in one equation? Not possible? No? Cannot happen in one equation? Okay, no. Alright, students, that's correct. To solve three variables, three unknowns, three equations. One variable, one equation. Two variables, two equations. Always जितने variables है उतने equations चाहिए. Let's see मेरे पास three equations है क्या? चलो देखते हैं. एक तो they have directly given AB. Yes, segment AB is divided into two parts, AD and DB. What is AD? X. What is DB? Y. So can I say X plus Y is 12? Definitely. Similarly, I can say Y plus Z is 8. And similarly, I can say from AC, X plus Z is 10. Yes, X plus Z is 10. So we have got our three equations. Now students, there are various ways to solve these three equations simultaneously. The best way is whenever you have three equations, add the three equations. Let's quickly do it out here. Yes, we can orally do this, right? We will add these three equations. Add left hand side, add right hand side. On the left hand side, I have 2x plus 2y plus 2z equal to 12 plus 8, 20, 20 plus 10, 30. What did I get? 2x plus 2y plus 2z is equal to 30. Let us take 2 common. X plus y plus z is 30. Yes. Now this 2 on the other side, multiplication becomes division. 30 by 2. X plus y plus z is 15. Yes. Let this be our fourth equation. Now students, extremely easy. X plus y plus z is 15. So if I want the value of x, I need to substitute the value of y plus z. Do I know the value of y plus z? Yes, definitely. Y plus z is 8. So what do I get? X plus 8 is 15. X is equal to 7. Similarly, students, quickly tell me what are the values of y and z from this equation. Solve and give me the values of y and z. Come on, quick. I'm waiting for you all. I want the values of y and z. Okay, I see y is 5. Okay, solve z also simultaneously. Y is 5, z is 3. Okay, all right. Okay, so I get the answers. People say y is 5 and z is 3. Let's check if they are correct. Okay, thank you so much, Rahul, Prathamesh. Thank you so much. Let's see. So if I need the value of y, I need to substitute for x plus z. What is the value of x plus z? X plus z is 10. So y plus 10 is 15. Y is definitely 5. Remaining 7 plus 5 is 12. You don't even need to substitute. 15 minus 12 is 3. Have we got x, y, and z? Yes, we have got the values of x, y, z. That is exactly what was asked. So please just at the end write AD is equal to x equal to 7, B is equal to y equal to 5, CF is equal to z equal to 3. Yes, so we have got all the values. Hence, we end here, right? That is what we needed. We have got the three values. Students, always remember, it's the best practice to write everything, the answer, final answer at the end should be written together like this. Should always be written so that the checker or the examiner can directly see, this will catch their eye, and directly you'll get your marks out there. All right, so always write the final answer at the end. Let's move to the next sum. Okay, now again another important sum. It's a sum similar to the previous one. Let's see why it is similar. ABC is a right angle triangle, right angled at A. Okay, so what we see is A is a 90-degree angle, such that again we have sides of a triangle given. AB is 6, AC is 8. Okay, find radius of the incircle. Students, I have always mentioned, whenever you have a center of a circle and points of contact, pay attention, we have 3 points of contact because sides of a triangle are tangents to the circle. So we have point of contact N. So let's join ON. Let's join radius ON. Also, we are going to join radius OL. And let's join the third radius OM. So we have joined this. Okay, we have joined this much. Now people pay attention. They want us to find the radius of the incircle. Now, first we are going to do reverse engineering. Radius, that means they want us to find ON, right? ON is R, OL is R, OM is also R. Find anything, we need to find the radius. Students, quickly pay attention. If you look at the radius, yes, now there are two ways to solve this sum. I'm going to show you all both the ways. The second way is already done out here. So I will do it the first way, and the second way I will explain it to you all. Now, radius, if you see, now pay attention. Again, what do we have? External points to the circle ABC. So from every external point, do we have two tangent segments? Yes, definitely. AL equal to AN. So I'm going to mark AL and AN as X. Similarly, BL equal to BM, Y. CM equal to CN, Z. Now students, pay attention. In the last sum, when we had X, Y, Z, we solved the sum and we could find the values of X, Y, and Z. So if I prove that radius is equal to either X or Y or Z, I can find X or Y or Z, right? From this information that we have. Pay attention, students. Look at this figure that we have. Quadrilateral ALON. Students, what kind of a quadrilateral do you think it is? Let's see. We have a right angle at A. ON is the radius to the tangent AC. So ON is perpendicular to AC. Similarly, OL is perpendicular to AB. Now, three angles are 90 degrees each. The fourth angle has to be 90 degrees in a quadrilateral. Yes, so quadrilateral ALON becomes a rectangle. Students, pay attention. Whenever angles are 90 degrees, it becomes a rectangle. Rahul, this is still a rectangle. You can say it is a square. Students, pay attention. Right now, we have just said that all angles are 90 degrees. If all angles are 90, it's a rectangle. Now, if you get adjacent sides equal in a rectangle, then it becomes a square. So pay attention. Let's look at the adjacent sides. ON and OL are adjacent sides, right? ON and OL are adjacent sides. So now it becomes a square. But the point is, we don't have to prove this a square. What we see is opposite sides of a rectangle ON. So let us look at opposite sides of the rectangle ON. ON and AL. They are opposite sides of a rectangle, and we know opposite sides of a rectangle should be equal. That means ON is equal to AL. That means R is equal to X. Our radius is supposed to be equal to X. Now students, from the previous sum, If three sides of a triangle are given to you, same like the previous sum, can you find x, y, z? Definitely we can find x, y, z. For that, AB is 6, AC is 6. We need the value of BC. What is the value of BC, people? Quick, can I find the value of BC? Quick, students, the third side of a right angle triangle. Okay, I already get an answer, 10. All right. Yes, students. Yes, very good. Yes, Prathamesh. Yes, Rahul. That's correct. From Pythagoras theorem, in a right angle triangle, yes, by Pythagoras theorem, we know AB square plus AC square is BC. 6 square plus 8 square is BC. So 36 plus 64, 100. 100 is BC square. BC is 10. So we get the value of BC as 10. Now, students, isn't this just like the previous sum? AB is 6, AC is 8, BC is 10, and what you need to find is XYZ. So I'm going to leave this to y'all. You know how to find X, Y, and Z when you have three sides of a triangle. Yes, get three equations. What are your three equations now? X plus Y is 6. Y plus Z is BC, which is 10. And X plus Z is AC, which is 8. You have three equations. Solve these three equations, and we just want the radius. That means you only need to calculate X. Just calculate the value of X, and that is your answer. All right. This is one way of solving the sum. Let's see the other way of solving the sum. All right. Now, the other way of solving the sum is also very easy, students. Pay attention. What we are going to do is we are going to draw some segments. We are going to join vertex A to O, B to O, and C to O. What are we doing, students? We are going to join AO, BO, and CO. Why? Because when you join AO, BO, CO, now you have three triangles. You have triangle AOB, triangle BOC, and triangle AOC. Now, students, pay attention to the concept that we are learning first of all. Can you calculate the area of triangle ABC? Area of triangle ABC, students. Yes, area of triangle ABC is very easy. It's half into base into height. Yes, we already have a right angle triangle. So it's half into base into height, half into 8 into 6, which is 24. Yes, half into 8 into 6, which is 24. Now, students, pay attention. This triangle, if we divide them into three triangles, yellow triangle, green triangle, and pink triangle, if I add the areas of three triangles, it is equal to the area of triangle ABC. Yes, if I add triangles AOB plus BOC plus AOC, it is going to be area of triangle ABC. Now, why are we taking that? Pay attention, students. Let's look at AOB. AOB has OL perpendicular to AB. Yes, we have a height and we have a corresponding base AB. So can I write AOB as half into AB into OL? Yes, definitely. AB is the base and OL is the height. Let's quickly substitute. AB is 6 and OL is the radius. So what do we get? Half into 6 into R is 3R. Similarly, BOC is going to be half into 10 into R, which is 5R. And similarly, AOC will be half into base 8 into height R, which is 4R. Now, students, we know adding AOB, AOC, and BOC should be equal to ABC. So we have done that. We have added AOB, BOC, and AOC. 3R plus 5R plus 4R is equal to 24. Adding LHS, we get 12R is equal to 24. R is equal to 2. Here we have directly found the radius and it is equal to 2. We have taken the radius as heights of each of the triangle. So we have got one equation in one variable, which is R, and we have calculated R from that. So this is the second method of solving. In exam, you can use any method, whichever is convenient for you all to solve the sum. All right, students? Okay. Any doubts with this sum? I would like you all to tell me if there are any doubts with this particular sum. Yes, students, any problem with this sum? All right, no, okay. All right, no problem. Okay, I see no problem. All right. Okay, students, quickly we'll just do another sum and then we'll end our lecture for today. Okay, just another sum and then we end our lecture. Now, students, pay attention. First thing, in such sums, this particular kind of sum, we need to understand how to draw the diagram. In case the diagram is not given to you, how do you draw the diagram? Prove the opposite sides of a quadrilateral circumscribing a circle. Okay, so when you read this much, what do you understand? There is a quadrilateral and it is circumscribing a circle. Circumscribe means outside. That means quadrilateral is outside. Outside whom? It is outside a circle. So if you want quadrilateral outside a circle, all the circle should touch all the sides of the quadrilateral. So we have drawn that. Now let's see what they want. They want that opposite sides should subtend. Subtend means make. Subtend only means make. So opposite sides should make supplementary angles at the center. Let's take the opposite sides as AB and CD. Yes, AB and CD are opposite sides of a random quadrilateral. Yes, definitely. Now, what is the angle that AB makes at the center? It is obviously AOB, right? AB makes angle AOB at the center. So basically, what do I need to prove? AOB. What is the angle made by CD at the center? It has to be COD. Students, pay attention. Angle made by a segment should have C and D. If I say CD, then C and D have to be the end points of the angle as well. Yes, end points of segment should be end points of the angle also. So CD subtends COD. O is the center, obviously, so COD is the central angle. Now, what do you need to prove? That the angles are supplementary. That means I need to show AOB plus COD is equal to 180. Students, pay attention. In such sums, you have to write what is given. You have to write what is to prove. So, this is just one pair of angles. I have another pair of opposite angles, right? That is AOD plus BOC is also equal to, okay, bear with that. Yeah, also equal to 180 degrees. So students, we have to also prove this. But again, geometry has this magic word similarly, right? You can just prove the first part and say similarly you can prove the second part. You can say that, or else in this case it is extremely easy, so we'll just go ahead and solve it. It's just another two steps. Otherwise you could also say similarly. Now that is about what we are supposed to do. But students, I have always said, if you have a center and points of contact between the tangent and the circle, always join the radius. Yes, you have to always join the radius. So you, as you can see, we have joined OP, OQ, OR, OS. And what do we know? Simultaneously mark the 90-degree angle. OP is perpendicular to AB, OQ is perpendicular to BC, and so on and so forth. Now, how do we prove this? We have already seen such kinds of sums. Whenever from an external angle, you have two triangles to the circle. Pay attention now. From an external point, two triangles we have. Which two triangles? Let me quickly name the triangles. AOS and AOP. Triangle AOS and AOP. Students, can I prove triangle AOS and AOP congruent? Yes, same thing. कब से वही कर रहे हैं. AOS and AOP are congruent to each other. Take whatever test you want. SSS, SAS, or RHS. You can use any of the two or any of these three methods, three tests of congruency, and prove that the triangles are congruent. Now, why did we do this, people? So that these angles, we need to talk about AOB and COD, right? Now, if you look at AOB, yes, I'm just talking about AOB. AOB is made up of two angles, right? Yes, AOB is made of two angles. Which are they? AOP plus POB. That means we don't need the bigger angle. What we need is smaller angles, this and this. That is why we are proving the two triangles congruent. And now, because AOS is congruent to AOP, can I say these two angles are congruent to each other? Yes, definitely. By corresponding parts of congruent triangles, these two triangles are congruent to each other. Let's name them as A and A. You can name them as X, X, A, Y, Y, do whatever you want. But these two triangles are congruent. So corresponding angles are congruent. I have named them as A and A. Students, whenever you get equal angles, it's best to give them a variable. So that it's just for the simplicity purpose. It's not a compulsory rule or anything. But for simplicity, name them as AA. Now can I say similarly triangle SOD, similarly triangle SOD will be congruent to triangle DOR? Yes students, if you have any problem with this, that why ma'am, why are these two congruent, you can ask me. What am I saying? SOD congruent to DOR, triangle SOD congruent to triangle DOR, same way. So can I say now these two angles are congruent to each other by corresponding parts of congruent triangles? I have named them as B and B. Yes, I have named them as B and B. Now it's very easy. Same way these two are congruent, CC, and same way remaining two angles are congruent, D and D. Now students, what do we have? At point O, we have 8 angles. And what do we know? At any point, sum of all the angles at the point is, yes students, sum of all the angles at a point is, I would like you all to type, what's the measure of all the angles around a point? Okay, Prathamesh says 180. All right, let's see. Let's see if it's 180. Anyone who feels 180 is not correct, something else. Okay, Rahul says 360. Interesting, two different answers. Remaining people, are you all sleeping? Okay, Atharva says 360 as well. All right. Okay. All right, students. So definitely at a point, sum of all the angles at a point is 360. Students, pay attention. Now, at any point, I can draw a circle, right? And we know that a circle is a 360-degree angle figure, right? A circle is always 360 degrees. So every angle or all the angles at O will be 360. So now can I say A plus B plus B plus C plus C plus D plus D is equal to 360? Yes, 8 angles at the center make an angle of 360 degrees. Quickly now, remaining few bits, 2a plus 2b plus 2c plus 2d is equal to 360. What I've done is I've just added all the coefficients of like terms. Students, you can add only coefficients of like terms. That's it. We take 2 common. So what do we get? A plus b plus c plus d is equal to, we have taken 2 common people. This 2 on the other side becomes 360 divided by 2, 180. Yes, we have taken 2 common out here. I have not written that step, so please understand. We have already done this before. When you take 2 common, in bracket you have a plus b plus c plus d, and multiplication on the other side will become division. 360 by 2 is 180. Students, look at a plus b plus c plus d. What we have got and what we want. AOB. AOB. Isn't AOB a plus d? Yes, AOB is a plus d. Students, pay attention. So, a plus D is AOB. And what is B plus C? B plus C, isn't it COD? Yes, B plus C is COD. So have we got AOB plus COD is 180? Definitely. Same way, look at AOD. AOD. AOD is A plus B. Right? I'm writing it there itself. And look at BOC. BOC is C plus D. So if we add A, B, C, D, what do we get? The same equation, 180. So we have got that. Hence, angles subtended by opposite sides of a quadrilateral are supplementary at the center. Hence proved. Yes, students, that is how we prove this sum. So once you prove 2 triangles congruent, remaining just say similarly. Use this beautiful magic word similarly. Just name all the angles, and this is what we have done. Yes, students, any doubts still here? If any doubts, kindly ask, or else we'll stop our session for now. Yes, quickly. If no doubts, then okay, Prathamesh, no, that's beautiful. Thank you. All right, okay. Yes, Rahul. All right, okay, Sneha. All right. Okay, thank you so much, students. So I hope you enjoyed the lecture, and that was a good revision for you all. Okay, thank you so much. All right, so we'll sign off for today. See you all in the next lecture. All right, yes, bye-bye. Yeah.